Welcome dear students for the online learning for the course Warehousing Automation. Now in the process of learning this course, as of now we have completed 7 presentations earlier, which started with introduction to warehouse process, then gradually delved into the challenges what we face in a traditional warehouse, then further it narrowed down with respect to the role of automation inside warehouses, then how it is going to transform the scenario, then we saw the benefits, then gradually we delved into warehousing automation categories, the levels of automation, and within which we had two types, digital versus physical. And earlier presentations we discussed about the physical type, within which intra-bound logistics, that is intra logistics, was discussed, and carousels it was discussed. So this is what the summary of the presentation what we had earlier. So now we'll get into the next, shuttles and cranes. Of course conveyor systems also will be covered in this particular topic. So to summarize the earlier presentation, it is like this, where anything which comes inside the warehouse, it is going to be called as inbound logistics, and the thing that after packing, the things which goes to the customers is called as outbound logistics. But either of these two things do not come into the picture of physical process automation. Only within the warehouse what we do is going to be accounted. So within the warehouse what it does is going to be our core agenda. So that is what we are discussing about. And now the earlier thing what we discussed was carousels. So carousels are custom built-in tailor-made boxes which can accommodate certain products of certain volume. So they are specially designed, developed for this particular activity. And there are two types of racks what we discussed, that is vertical as well as horizontal. The benefits, the functionalities was discussed earlier. So vertical and horizontal or the two types, and this is going to be for the case of vertical. So there is an ergonomic window of the user's waist to chest height, that's what the windows location, access windows location is going to be, and within which we can take the products out. For the case of vertical, it is going to be perpendicular to the floor surface, and for the case of vertical, again it can be stacked one above the other, likewise it can be dealt off. So here it is going to be volumetric utilization. Perhaps when you see for the second category, heavyweight components, because here the load is going to be taken care by the two vertical arms which are going to be provided on the either end, but here it is not so. So everything is going to be mounted on the floor, the track like structure. So therefore whatever the weight we are going to put it onto the carousel will be taken care by the base of the entire system. So these all are the things what we discussed. So now we'll get into the next thing called as shuttles. So the term shuttle means usually they are small transport equipments which are going to move from one particular point to another point on a to and fro case. They are going to travel to and fro. So a warehouse shuttle system is a mobile cart. It's a mobile cart that shuttles. Shuttles means somewhere moving from a fixed point, often to and fro movement can be expected. Items in automated pallet racking. It's used to store and retrieve stock tortes. Earlier we saw about torte, shuttles, trays or cases in storage buffer. So along a prescribed path within a particular distance, they are going to move front and back. That is what shuttle is all about. Probably you would have heard something like shuttle buses or so. So it is of the same nature. So these shuttle systems are invaluable in warehouses that use GTP methodology. GTP means there will be racks will be there, and those goods will be taken to one person. That is, on one end of the rack system a person will be waiting. So this shuttle will go to the respective point, it will collect the product and again it will bring the same to the person. So that is what GTP methodology, and they have high density racking. So that means we can stack a number of things theoretically speaking. So they travel the depth of the racking to pick up or deposit pallets at either end of the racking structure. So they can move to the extreme end on either cases. Therefore, it is possible for us to access the rack all along the length, and shuttle can move to the extreme point so that it can be easily accessed. They are ideal for warehouses with lower SKU. I hope you guys might have would have got this idea earlier. If not, I'll come again. SKU means stock keeping units. So stock keeping units counts and high throughput, which means frequent loading and unloading of a large number of pallets per storage unit. So usually for not very so small component as well as not heavy bulkier component, somewhere moderate cases, yes, these things are going to be a boon for such category items. They speed up to the circulation of outgoing orders and incoming replenishment goods and makes it easier to manage racks with deep storage buffers. So that means that they can be used for either cases, that is to bring the product from the rack to the person for the case of packing and delivery to the customer, and when you want to replenish you need to restore it again so that you can use for the next time. So for the case of replenishment also can be used, and that's what we discussed about tortoise shuttles. So four ways, that is one front one back, left side it can load, right side it can unload, or left and right can be vice versa, whatever may be the cases. So four ways any shuttle is capable to work on. Shuttle run on rails integrated into the racking system and carry loads from one end of a rack lane to the first available storage position or retrieval point. So it is simple, as simple as this. It's going to run all along the length of the rack, and there are going to be rails connected to these racks at various levels. We can have, theoretically speaking, various levels we can have. They are typically controlled wirelessly via remote Wi-Fi or integrated warehouse management system that send pick or put away commands. By means of simple commanding mechanism, we can bring back, that is to and fro operation is highly possible as well as feasible. Vertical movement between rack levels is enabled by stacker cranes, transfer cars or elevators that shuttle the mobile units up or down to appropriate storage heights. See, now this is what we need to understand. Shuttle will always be used only for the case of horizontal movement. If we have vertical means, obviously we should go for some other thing, because shuttles are not capable to go ahead for vertical case. Only for the horizontal case they are suitable. Vertical cases we need to go for some other mechanism like stacker cranes, transfer cars or elevators. In short, lift. The lift is called as elevator. So we'll see, that's what the next topic is all about. Crane is suitable only for vertical case, not for the horizontal case. So operations use FIFO or LIFO strategies depending on rack accessibility. So FIFO means it's a queuing concept, first in first out. Again, LIFO is also queuing concept, last in first out. So you need not to worry at this junction, because we are going to discuss the second unit is going to be with respect to queuing theory. So there we'll be dealing a lot with respect to this queuing strategies, different types of queues, queue behavior, everything we will be learning there. So you need not to worry about this at this junction, just know the concepts. So FIFO means first in first out, first it comes and first it goes. So let me give a very simple example. There is a toll plaza, there are several lanes. For example, when we travel towards one particular area, there might be some 4 or 5 lines might be there. So within the lanes, one car comes first, okay, whichever comes first that gets served and that moves out. Clear? So first in first out, not the one which comes at the last will go, okay, that is not the thing. Whichever the car comes or whichever the vehicle comes in that particular lane, whichever comes first will get served, that is fast tag will be accessed and they can make a move. So coming for LIFO, last in first out. Another very simple example, maybe you would have been submitting some record or observation to a faculty on the lab classes or some other classes where things would have got stacked up. So whomever has submitted last, that is the notebook which is on the top, will be accessed first. They will be served first. So this is one simple concept called as last in first out. One who has submitted last will be taken first and they will be serviced. So that is how it goes on. Of course, there are different types of queues are there. So there we'll see a lot about it. Now we'll see the different types of shuttle classification. So this is very important. Why? Because based on this only we will be able to determine what type of or what is the nature of shuttle we wish to have in the warehouse. So first type is 1D pallet shuttle. 1D pallet, that is one dimensional pallet shuttle. So one dimensional means it will work only on one side. Either it can be forward or it can be backward. So another thing will be idle. It will be on the idle. Only single pallet will be there. Pallet is nothing but a platform. The platform, only single platform will be there. You can use it only for one, either to load or to unload. So that is the simplest case. That is the opposite motion will be dummy. It will be idle. So moves along a fixed rail inside one storage aisle, can load unload pallets from the front end. Eliminates the need for aisles to increase storage density, semi-automated or fully automated operation. Why it is called semi-automated means, see, if it is at an angle, so what happens is only when you pull it we need energy. So return, obviously gravitational force will take care. So that particular case we call it as semi-automated. Fully automated means it should be parallel, right? It should be parallel to the warehouse surface. So therefore either cases we need to take care of, that is load force has to be offered. Idle applications, warehouses storing limited stock keeping units with stable order profiles. So good for deep line storage to increase density. So these all are the idle cases where we use. So keep in mind it is applicable only for one movement. To and fro means either to or fro will be the productive and the other case will be a non-productive activity. And next, 2D pallet shuttle, also called as mother-child shuttle. That means two-dimensional, forward as well as backward, plus side to side, uses lifts to access multiple levels. So here it can go forward and backward, number one. Even it can go to the side. Side means not horizontal, vertical. So vertical it can take up to the next line. It acts as a lift, that is combination of the earlier 1D, but of course second axis is going to be given load, and additional to it, it is going to act as an elevator. So consists of a mother shuttle that moves along aisles and a smaller child shuttle that moves within racks. Enables flexible and efficient storage and retrieval, integrates automated picking and replenishment. So it can be used for both the case. So two pallets will be there. One will be the mother pallet that acts as a lift, and within which there will be another pallet called as child pallet, which is going to move for the front and back direction. So that is how two dimensions, front and back, top and bottom. So either cases it is going to be connected. So two shuttles within one system, if they are integrated, that's where we call as mother-child system. High density warehouses requiring multi-level access and greater flexibility improves throughput and space efficiency. So one system itself will take care. Then the next 3D pallet shuttle, that is four-way shuttle. Three-dimensional forward, backward, side to side and vertical. Side to side and vertical. That means earlier case, two different pallets integrated together. Now same pallet, that is same system will do three activities. That is where it is called as three-dimensional. Shuttle can move across multiple axes independently within the racking structure, accessing pallets at different depths and levels without external lifts. Integrates shuttle unit, racking and control systems for advanced automation. So complex high throughput automated warehouses demanding maximum flexibility in storage and retrieval across all dimensions. So this is where it is highly used. Roaming shuttles. Multi-axis with additional conveyor integration. So roaming, the name itself tells, they don't follow any particular path. They are free to be used in all cases. Combines 2D shuttle movement with lifts and buffering conveyors for direct product delivery to pick stations, minimizing shuttle traffic jams and enhancing throughputs. So here there is no restricted route. It is 100% available based on the demand. Based on the demand, we can directly ask to one particular point to go and pick it up. So but earlier cases we need to abide by traffic. Traffic will be there in one particular lane, something like a train in one. If it is a single track means only one train can either go or it can come. In a same track, two trains of opposite direction can never go. So likewise, we need to get into the scheduling activity, which goes first, which comes next. So till the arrival of the shuttle, the track has to be kept engaged so that other will be waiting. Likewise, several routing rules comes into picture, but here no such things are there. So it is multi-axis, therefore directly it can go into. That's what the versatility, the flexibility which can be offered by roaming shuttles. Operation requiring high throughput and avoiding shuttle congestion. So this you need to know. So earlier cases when traffic is going to be high, those cases we can go for roaming shuttles. Adaptable to various SKU velocities and product types. Stock keeping units velocities. So here what is the term velocity refers means the rapidness of delivery. So how far you are able to deliver the product with least possible time. So the time is considered here as velocity. Next, cranes. So this is one simple crane which we can see in any shop floor. So now the clue what I wish to give to the students by seeing this image is just observe the image. There are two ends are there and this something like a gantry type. It connects the either end of the warehouse. So now what is the peculiarity here is in between there is no distance, and very simple, the distance between these 2 points, that is between this particular point to the end of the other end of the crane, will be at least some 100 feet. So now this is how the warehouse has to be designed. So we need to, as a warehousing engineer, we need to give input for the civil engineers so that they can do the structural thing. So this is what the last topic what we are going to deal about, layout, how to design the layout and how to give information for the civil engineers to go ahead with. So cranes. So now cranes, obviously they need to work in the horizontal case, but the hoist unit will take care. That is, this particular unit will take off the vertical movement and this entire will be moving front and back. Therefore, we can get the either movements. So gantry type, it's completely gantry type, X, Y and Z. Three axis comes into picture. Cranes. A warehouse overhead crane is a mechanical lifting system that can move a load horizontally and vertically within a delimited area, usually rectangular or square. That's what I told you. It is Cartesian coordinates, gantry type. This type of crane consists of one or more girders equipped with a trolley with a traverse travel motor and another one for lifting. So usually there will be two motors will be there. One motor for horizontal movement, another motor for vertical movement. Of course, it is also horizontal but other axis, and the third one for vertical. So likewise we can go ahead with. So purely it is a gantry type, that is X axis, Y axis and Z axis comes into picture. Warehouse overhead cranes are equipped with a lifting device known as a hoist. So the hook which is going to lift on the vertical axis is called as hoist, which lifts the goods and moves them to the appropriate area. The operator using a remote control operates the system without exerting any force on the load. So operator is not going to lift everything. Okay, he is going to just operate the device and the device is going to take up the load. So something like a remote or a joystick, the operator is going to operate the thing, maneuver. He is going to maneuver the load. He is not going to lift the load. A warehouse overhead crane consists of various components and accessories that can make it possible to lift and move loads safely from one place in the facility to another. So from one point it is going to take for the other point in horizontal direction on either cases and vertical. So directly it is going to work. So the lifting system is made up of a bridge-like overhead structures, that is either end it is going to be connected. A bridge-like structure is going to be connected. So it has a girder, set of girder that provides integrity to the system. That is, either sides are connected by means of a section. So it is going to give very good rigidity. So the main girder usually has rails on which the trolley moves goods horizontally. So on the rail, it is going to take the load here and there. So that is how it is going to. So it is going to slide. It is going to facilitate the sliding of the load. Loads are lifted by means of a hoist integrated in the trolley. So this unit will be having a hook-like structure attached separately to a motor. So therefore, they can be taken from top to bottom. So vertical movement is made possible. So usually it can be a hook can be there, a rope, a cable or chain will be there. Usually they minimize the load, clear, rather than a belt or other thing which can't be reliable. But these things are going to be reliable even for bulkier cases. So usually they are fitted with a hitch system so that the hoist can easily pick up the goods. A hitch is nothing but a self-locking hook. So the moment it locks, it is going to grip nicely. So that's how the design is all about. Now, which particular case where we can go ahead with when you have a bulkier unit, when you have a bulkier unit, not for small, pretty small components. When you have a bulkier component, yes, it can be easily used by means of a crane. So there are several safety features are there. So that has to be considered, and moreover it is going to be an accolade. It is going to be an additional added benefit where limit stops are there. So beyond one particular point it is not going to move. So again, to go ahead with the safety feature, just let us compare to the lift car of a electronic hoist. That is nothing but a lift what we have in a building. Clear? So in a building, a lift might be having so many maximum number of passengers, 5 passengers or weight, whichever comes first. Okay, the moment extra load comes, immediately we have a warning system. So that warning system will warn us that overweight or whatever may be the case, and immediately one deboards, then obviously the system works. Likewise, here limit switches are there, then strain gauges are provided to identify the load, so etc. All sorts of safety features are completely considered. So this is the first type, gantry type. So gantry type means it's going to be bulkier. It is free from the Varro structure. It is not dependent. It is only dependent on the track, rail track, similar to the railway track. Yes, that is where it is dependent. See, you can see there are tracks over there. So it is going to move front and back. So that is how it is, gantry type. And the next one, a jib crane. Jib crane means one end it will be fixed. That is, one beam will be fixed and this is going to rotate. This is going to rotate on 360 degrees. In addition, this unit, the hoist unit, also will move here and there. That is on the horizontal case, in addition to it vertical case. So that's how it can work. But the maximum is restricted. The maximum value it is restricted, that beyond this particular point the unit cannot move. So this is another type. The next, workstation cranes. So these are specially custom built in and tailor made case. That is for the working area. Within working area, we know the route in which the products are going to move. Usually it is used for bulkier items. Bulkier items. So we can station like this, station 1, 2, 3, 4 in particular fashion. So first, once it goes to the first station, gets the work done, then it goes to the second, third, fourth, likewise. So these are specially developed. The next, monorail. So monorail means only single girder. So this is called as girder. So only one. So one unit alone it will be moving. So usually the weight is restricted. So to summarize, what we discussed today is, on the second material handling system, we discussed about shuttles. Shuttles are capable of doing horizontal as well as vertical based on the nature. They can go ahead for product switching. And coming for the next case, crane. So purely it is developed for heavy and bulkier things. So with this we finish the physical process automation, especially focusing on material handling. So next we'll discuss, in the next presentation we'll discuss the further topics. So any doubts, kindly note it down. So during offline class we'll get the doubts resolved. So thank you, honors registered students. Thank you.